Alright guys, so this example gets a little trickier. When I look at my original problem, I'm looking at my coefficients again to see if any of them match. I'm looking at the x's and these don't match, -2 and -6, and I'm looking at the y's and they don't match either. So uh, I have to try to make them match. And what I can try to do is I can say, how can I get these coefficients to match? And what I need to think about is the least common multiple. We did work with least common multiple earlier in the week, and really what that means is I'm going to look at this -2 and the -6. I want to try to make them match. Or like in the last problem, I can have one be positive and one be negative, but the number itself has to match. So I'm thinking to myself, the least common multiple here would be 6 or -6. If I took this top equation and multiplied the whole thing by 3, I can't just multiply one number by 3. If I'm going to do it to one number, I have to do it to every number in that equation. So this becomes like a giant distributive property. Everything gets multiplied by 3. So that new equation would be -6x minus 15y equals 15. And now I would have a -6x, and in the second equation another -6x, so they match. I'm just gonna move this equation over here right underneath it. Not changing it, I'm just moving it over so they're on top of each other. Now, since these match, I should be able to subtract them and eliminate that x variable. So a -6x, I would have to subtract. And you have to think to yourself here, a -6x minus -6. When you have minus negative, it turns into plus plus. So I'm really doing -6x plus 6x, which is going to eliminate. Then I have -15y minus -8y. So it's like -15y plus 8y, because the minus negative turns into plus. So that's going to give me a -7y. And then I have 15 minus a positive 22. So 15 minus 22 is -7. And this is going to work out nicely because I can divide both sides by -7 and get that y equals 1. That is only part of my answer. I have to then go back to one of my original equations and plug in 1 for y. I'm thinking I'm going to go with this top equation before I multiplied it by the 3, the original -2x minus 5, but I can plug in 1 for y equals 5. So that would be -2x minus 5 equals 5. I can add 5 on both sides, which will give me -2x equals 10. Divide by -2, and that's going to give me that x is -5. So I have my x value, I have my y value, and that is the point where they would intersect if I graph these. So same steps as before, but the only thing I had to do differently was I had to take this top equation and multiply it by 3 so that I actually had some matching coefficients here.